measures of position. This we know already. I'll just formalize the understanding. We all give tests and we know the first, okay? So this is helps us understand the position of specific value in the data set, okay? Helps us understand relative position of data of a specific data point, in the data set. So that's what it measures. And there are ways to measure this: percentile, quartile, and then we'll talk about one of the range metric also. So let's see percentile first, most common one, percentile. We give exams and all the scores that we get, like JEE, etc., etc. nowadays, GMAT, wherever you go, you will get percentile. What is a percentile? So percentile is nothing but, what do? We get percentile out of 100%. That's the name is coming. So percent, this cent word is coming from 100, per 100. So per 100, what is there? So percent means we divide the data into 100 equal parts, okay? This is a way to divide data in 100 equal parts. Okay? And then whatever is the percentile, say for example, out of 80 people, if my percentile is, say for example, I have got 80th percentile in any test, that means that at least, okay, at least 80% of the people scored less than me. Or in other words, my score is higher than at least 80% of the people. Okay, my score is higher than 80% of all other people who took the test. Of all other people who took the test, who took the same test. That's what 80 percentile means. Okay, you divide the complete, if there are 1000, we divide it into 100 parts, and then out of, if your score is, say for example, out of 100, if you scored like 67, and still your percentile can be like 80th, because the number of people who scored 67 or more is only 20%, and 67 or less is 80%, because you divide the complete scoring into 100 and number of people, who percent of people, not the number, the whatever be the count, 80% of the people scored less than you and 20% of the people scored more than you, and you are on the 80th percentile. That's what it means. Simply, if I write it formally, like kth percentile, kth percentile, say percentile k is equal to at least, what do we say, at least k percent of data values are less than or equal to it, less than equal to given value, equal to it. Okay, let it be. Percentile, everybody, we use it, and now I think it's formalized and it's clear. Okay, so that's your percentile. Now let's move to the next one, that is quartile. Quartile is again the word itself. Quartile. Quartile is coming from quarters. We divide the data into 4 parts. Percentile was 100 parts, quartile is 4 parts now. We divide the complete data into 4 parts. The relative position was with respect to 100 parts. Here I divide the data into 100 parts and put myself there, or whatever the score I have, and then I see out of 100 parts, where do I stand? In which part I am? Out of 100 parts, I am on the 80th part. 80% people are below me and 20% are above me in a test. Similarly, quartiles are divide the data into 4 parts, and I lie in which part. Okay, so that's the idea of quartiles. So these are against percentiles only, special percentiles. So that was 100 parts, and now if you divide the complete thing into 4 parts, then each quarter would be 25, 25, 25, 25. So that is like 25 percentile. then 25 to 50 percentile, 50 to 75, and 25 to 100. So these are the 4 parts, and these are the 4 quarters, okay, or quartiles. I hope that is clear. So special, these are special percentiles. Special percentiles that divide data into dataset. Data, when I mean the complete dataset, all n data points. Dataset into 4 parts. Okay, and this is again not affected by outliers. Not affected by outliers. Okay, simply this is a relative comparison. So again, everything this is whatever the position is again relative with respect to the data set. That's for the whole idea. So what are the 3 quartiles? So we write it as Q1, Q2, and Q3. These are the 3 quartiles that we measure. So this is like 0 to 25 percentile. This is percent means percentile. Write percentile itself so that you don't confuse. That is above, okay, up to below which, okay. So Q2 is up to till 50th percentile. So I'll write up to 25th percentile, then up to 50th percentile, and then this is up to 75th percentile. Okay, and 50th percentile means the position is 50th, that is in the middle. So generally the Q2 end is, this is the median. So median is the measure of the percentile also. So the 50th percentile is the median. Okay, so for example, let's understand. And how do we calculate it? So this will be, let me write it, this will be this will be equal to Q1 is n plus 1 as it is into 1 by 4 into n plus 1 into 2 by 4, that is half, is equal to n plus 1 into 3 by 4, that is quarter, 75 percentile. So these are the 3 quartiles, Q1, Q2, Q3. So data less than 20%, 25th percentile, less than 50th percentile, and less than 75th percentile. Let's understand quickly with an example. So we have one data, let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and let's have an outlier 100, so that I'll show you it doesn't, outliers don't impact because it's relative position. I'm not taking into account these numbers. I'm not summing or adding it up or multiplying anything, so it won't impact. So that's the whole point. So I'm not doing any mathematical operation or including it in my calculation. I'm just taking the position, then it won't impact, and that's how I'm outlier proof. So what will be my first quartile? Q1 will be equal to, how many data points are there? 10 plus 1, 11. So this will be n plus 1 will be 11 plus 1 into 1 by 4. That is 12 by 4. That is equal to 3. So this will be my, this is my Q1. Q2 will be 12 by 2. This will be 6. So this is your Q2. Similarly, Q3 will be equal to 12 into 3 by 4. This will be equal to 9. So this is your Q3. So these are my 3 quartiles. So if you see, even if you have 100 or 1000, it's not impacting where my Q1, Q2, Q3 will be. And now what are the 4 parts? If you see, this is dividing into 4 parts. This is my first part. This is my second. Let me do it different color. This is my second part. This is my third part. You see, this is my fourth part. First part, second part. So quartiles are 3, but the parts they are 4. Q1 is till 25th percentile, Q2 is till 50th percentile, Q3 is till 75th percentile, and then beyond that is till the 100th percentile. So these are the 4 parts which it is dividing, and these are the metrics Q1, Q2, Q3. This is how we measure it. Very important. Okay, and then quartiles are the, so we have, when we will see and again when some plots when we do. Okay, so there is something called box plot. So it is like this. I'll just draw it in a rough way. So it looks something like this. Let me see. This is there, and there will be some big box like this. You will see some plots like this. Okay, and there will be like this, and like this, and then like this. So this is your box plot. Okay, so let me write all. This is the minimum value. This is the minimum value, starting point. Okay, and this is your Q1, this is your Q2, this is your Q3, and this is your max value. Okay, Q2 is also your median. So this will also tell you where your median lies. So again, if you see here, it is dividing the complete data into 4 parts. This is your first part, okay, and then in the second part, and then the third part, and then the fourth part. So that's what your box plot gives me. First, second part, third part, fourth part. I hope now quartiles are clear. And then next is my IQR. So that's a measure of a range or dispersion of data, spread of the data. So IQR is inter quartile range, IQR. This is the most common method to identify outliers. Okay, so this is again a single number, gives me this single number that gives the measure of middle 50%, the spread of measure of spread, or I'll just write spread of middle 50% of the data with respect to the percentiles, 50% of data. Okay, and this is a more robust measure of spread than range, because range is impacted by outliers. I'm just taking the middle 50%, this bigger box. This is the middle 50%, this is first 25%, this is the last 25%. So this, the data in the box, this is your IQR. So this will give me the middle 50% of data where it is lying. So it is not impacted by the minimum or maximum value. So that's why it is more robust than range. More robust to outliers than simple range, because range is just max minus min, right? Say for example, this will be like the middle 50% means this range. What will be this? Starts from here and here. So this will be like Q3 minus Q1. This is your middle 50% of the data. This is first 25%, last 25%, and this is your IQR. So your IQR is equal to wherever your Q3 lies minus Q1. So here in this data, whatever we had, where is my Q3? Q3 is at 9 and Q1 is at 3. So what will be my IQR? Here itself. If I want to calculate IQR also, so my IQR will be Q3 minus Q1. This is here equal to 9 minus 6, 9 minus 3. That is equal to 6. This is your IQR. Simple, very simple. Okay, and this IQR is used for outlier detection. How? So this is used for outlier detection. This is the most common tool when I am doing exploratory data analysis, right? So I use IQRs for one of the methods to see after the plot, etc. Right? This is also one of the measures to understand the what are the data points that may be potential outliers. It gives me that information. So how? So again, I'll write it for you. IQR is a standard tool during EDA tool for outlier detection. Outlier detection. So we define some fences, some boundary, and any data that falls outside the boundary is a potential outlier. Okay. So based on the IQR, I decide some more extra. I'll give some padding and I'll decide these are the boundaries. This is my mental 50th percentile, and I'll give some boundaries, extra padding on both the ends, and anything that falls beyond that, that will be a potential outlier. I'll flag them as outliers and leave it for the expert to review whether it's an outlier or not. So let's see. So values that fall outside the boundaries, outside the fences or boundaries, the fences that I decide, guarding boundaries, are called potential outliers. Okay, for example, so I'll define, how do we define the lower and upper fences? So lower fence is equal to, so this will be Q1 minus 1.5 into IQR, and the upper fence, the upper boundary, is equal to Q3 plus, so anything, again same thing, 1.5 into IQR. So this is your, I'll take the same example, let's copy it, and let's see what are the outliers in this data. So it can, whether it can flag potential outliers or not. So what will be my lower and upper fence? So my IQR was equal to 9 minus 3, that is equal to 6. So what will be my lower fence? Is equal to 3 minus, so my Q1 is 3, Q1 minus 1.5 IQR is equal to 3 minus 1.5 into 3, right? 1.5 into IQR, right? IQR is 6. So this will be 3 minus 9, that is equal to minus 6. That's my lower boundary. Notice my upper fence is equal to Q3 plus 1.5 IQR. Equal to 9 plus 1.5 into 6. This is equal to 18. So this is my upper fence. Anything beyond this, greater than this, is an outlier. So if I look at my upper fence, lower fence minus 6, so any values less than minus 6? No. But if I look at the upper fence 18 and so I will see that in my data there is 100. So I can mark this value, I can flag this value as an outlier for the expert to review, check whether this is an outlier or not. And they can decide whether this is an outlier. The subject matter expert will understand. Okay.